So hello everyone, welcome to the lecture number 2 for the rocket propulsion, and myself Ujjwal Srivastava. I am doing my master from IIT Kanpur, and guys, I have given my number over here. So if you need any guidance from my side or if you want to contact me, please contact me on this number. So as we studied in the last class uh, for the rocket efficiency, so let's continue. So till now we have done for the equation 5th. So today I am not using my note, you can say pen tab. So I am using my iPad. So please be patient with me because today I have only purchased. So it will take some time to understand all this, but still let's continue. So in the last class we were studied the we have studied till here, that is a propulsion efficiency for everything engine was something like 2 alpha divided by 1 plus alpha. It was like this, right? Now let's continue from here. So you already have mentioned this alpha is nothing but your VA by VE, that is your flight speed ratio. Fine. Now let's understand what is this actually mean. So first we write some wordings. So write a note. Propulsion efficiency of the order of 60%, around 60%, are considered reasonable. From an overall operation point of view. It means that means the propulsion efficiency will be around 60% for the whole aircraft. Let's suppose if aircraft is going from here to here, let's suppose point A to B, then the propulsion efficiency for this aircraft will be a 60%. Fine. Now let's further analyze this. So from equation 4 and 5, from equation 4 and 5. What was 4 and 5 equation? Please see your note, right? So F is equal to m of A into VE minus VA. That means mass flow rate of air into velocity at exit and velocity at inlet. So if you take the mass flow rate another side, that is a F divided by mass flow rate of air is equal to V minus what's happening V minus VA. Fine. Now if you take the VE common from here, so you will get around F divided by MA into VE, that is equal to 1 minus VA by VE, and the VA by V is nothing but your flight speed ratio, that is your alpha. That means two equations we have got in terms of alpha. The first one is the propulsion efficiency for everything engine, that was your 2 alpha by 1 plus alpha. Then second equation was F divided by mass flow rate of air into velocity at exit is equal to 1 minus alpha. Fine. Two equation you got. Now let's understand the graph for this two equation with the alpha. So write a plot. So first you write the plot of f divided by ma into va and propulsion efficiency with alpha. So write one neat graph. First you draw axis. Fine. Suppose this is your origin. Okay. Suppose this is your alpha over here, and here you are having the f divided by ma into va as well as propulsion efficiency. Fine. So if you now you understand this. Okay, now you put some values. Then after we'll let me take a small of this. Okay. Okay, fine. Let's now you understand. Let me take a of this little bit. Just a bit here. Alpha. Fine. Now understand the alpha and propulsion efficiency. Fine. So in this equation, if you put alpha is equal to 0, then you will get 0 efficiency. Fine. Now fine. Now if you put 0. If you put 0.2, then you will get propulsion efficiency is around 0.33. Okay, 0.4, then you will get around 0.557 of wait. Zero 0.575. Again, if you put 0.6, then you will get around 0.75. Please find all this value after putting the alpha value in this equation. Fine. Okay. What is happening here? Yeah. So 0.6, then you will get 0.75. Fine. Then after, if you put 0.8, then you will get around 0.88. Fine. Again, if you put 1, then you will get 1. Fine. So now, if you draw the graph for this, let's suppose the alpha value is 0.2, 0.4, 0.6, 0.8 and 1. Similarly, the propulsion efficiency is around, suppose from here it is 1, 0.8, 0.6, 0.4, 0.2 and 0. Fine. So you will get around here So we will get a curve like this. Right? So from here to here we will get 1, and from here to here we will get around 1. So now you understand this. So if you put alpha is equal to 1, then you will get 2 by 2 is equal to 1. That means the propulsive efficiency will be 1. That is the maximum propulsive efficiency. Now you understand, if you put alpha equal to 0, then efficiency will be 0. So if you are increasing the alpha value, the efficiency are increasing. And what is the alpha value? Alpha value is nothing but your VA by VE is equal to alpha. That means you are increasing the flight speed. That is why alpha is increasing. Fine. Now you understand what is happening with this. Now you understand what is happening with this. Okay. So in this equation, if I take this, so in this equation, okay, if I put alpha equal to 0, then I will get 1 here. If I put alpha equal to 1, that means this here, then you will get 0. So from here to here, if you put alpha equal to 0, then you will get 1. Fine. If you put alpha equal to 1, then you will get 0. And for different value of alpha, you will get a slope that is like this, a straight line. It is a straight line because it is a graph for a straight line, you can say, right? Okay. So this is nothing but propulsive efficiency, and this is nothing but your F divided by MA into V. Fine. Now write some wordings about it. Right. Bullet point 1. So if alpha greater than 1, that means VA is greater than VE. Fine. Then the developed thrust is negative. How? Because in the equation 1 minus alpha, if you put alpha greater than 1, that means the whole term will be negative. So the thrust will be negative, right? Okay. Then negative, and thus for an air breathing engine, fine. Now you understand this. Now the maximum efficiency is obtained at alpha is equal to 0. 1. At which propulsive efficiency will be equal to 1. We know this, right? And the thrust will be equal to 0. So apparently the propulsive efficiency, or you can say the propulsive unit, are most efficient when they do not work. That means if engine is not working, that means if the thrust is 0, that means engine is not working, because engine is used to generate the thrust. If the thrust is 0, that means there is no work for the engine. That is why the efficiency is maximum. So efficiency is maximum, but it is not a reasonable case because you need to generate the thrust from the engine. So now you understand. So no work, non work. Fine. Now right. 2, I mean, in order to obtain non-zero thrust, of course we need non-zero thrust and have a propulsive efficiency that means what it is saying is, suppose in order to obtain a non-zero thrust means we don't want a zero thrust. That means at alpha equal to 1 it is not possible case because we need to have the non-zero thrust. So alpha equal to 1, that is not possible case. So there might be two cases, either alpha less than 1 and alpha greater than 1, right? So non-zero thrust means what? See, we need either alpha less than 1 or alpha greater than 1. But we already seen over here, if alpha is greater than 1, that means we have a negative thrust and there is no meaning of negative thrust. That means your drag will negative thrust means nothing but your, see, thrust is negative, that means your drag will be more. Thrust is negative means more drag. So you need to supply more engines. You need to apply more fuels to overcome this drag. So the drag will be more. So there is only one case. So this is not applicable. So there is only one case. Alpha must be less than 1. So now right. In order to obtain non-zero thrust and have a propulsive efficiency, we should let alpha be the less than 1, right? Why we are going for 1, less than 1? I already told you the you can say the reason why you are not considering alpha equal to 1 and greater than 1. Fine. So you need to go to less than 1 because only one possible solution over here for the get a positive thrust or a reasonable thrust. Fine. That is, if alpha is less than 1, that means alpha less than 1, that means VA by VA is less than 1, which implies that the VA is less than VA. Fine. So so now you understand the whole aircraft in our atmosphere is flying on this concept. VE is less than the VA. VA is less than the VA because fine. Now you understand one more point over here. So the jet. So now this is called as the flight speed. This is called as the jet speed. Jet speed means exhaust speed from the engine. So from here, if you take alpha less than 1, then you will get a thrust, because from this equation, from this equation, if you take alpha is less than 1, that means it will be positive. So positive means the thrust will be positive, so the plane will go forward. Fine. Now okay, so now you write for the non-air breathing engine. So this is the case for the air breathing engine. everything in there. Now you write, let me take a little bit, fine, okay. Now you write, the next topic is, that means we have done propulsion efficiency for everything engine. Now let's go for the non-everything engine. So write the propulsive efficiency for non-air breathing engine, that means rocket engine. So now right, in order to or of you can say, in order of rocket engines, the definition, or by the definition of propulsive efficiency, I think my pen is when I'm writing on my pad now, so the pen is getting some sound is there, so please ignore this sound, please focus on the lecture, right? So now you read, so we know the propulsive efficiency is nothing but your V by A. How I am writing this, please go and watch the previous lecture. VA plus half mass of the fuel into velocity at exit as whole square minus half mass of air into the velocity at h square. Fine. So now you understand this. Here, mass of fuel is nothing but your mass of fuel flow rate. Fuel flow rate, or you can say the mass flow rate of a fuel flow rate. But this mass flow rate of air is nothing but your oxidizer, right? Because in our rocket engines there is no any air from atmosphere. So this mass flow rate of air is nothing but your oxidizer flow rate. That is a mass flow rate of oxidizer. So if this both the things, suppose this is your black box, fine, black box. So this both the thing we have to add from here, mass of the fuel plus mass of oxidizer to mix and start the combustion. So the both things together, I'm calling it mass flow rate only. That is a mass m dot. So if you take common from here, so now you understand. The propulsive efficiency, so it becomes the propulsive efficiency is nothing but your VA divided by FVA plus half mass flow rate of into VA square minus VA square. What I have done is, I have taken this mass flow rate of fuel and mass flow rate of oxidizer as a m dot, and now I am taking common from this. So half m dot VA square minus VA square. That's what I have written over here. So now we know that for optimum condition, fine, that is a PE is equal to PA. All these things I have already told you. So F is nothing but your m dot into V. So if you put over here in the place of F, so you will get noun, or you can say, okay, if you take common from here, F divided by m dot VA, so it will equal to 1. to 1. There is a one equation. So we have to draw once again for this. Now if you put over here in propulsive efficiency for the non everything engine, so you will get around m dot VE into VA, fine, divided by m dot VE into VA plus half m dot V minus V to the whole square. So from here m dot will be 1, and if you expand this as a whole square, V minus V the whole square, so you will get off around this 2 VE by V into VA into VA square plus VA square. Now if you divide from by the VE, or if you take common from this, so you will get around 2 alpha divided by 1 plus alpha square. So the propulsive efficiency, so therefore the propulsive efficiency for non-air breathing engine will be equal to 2 alpha divided by 1 plus alpha square, that is equal to 2 VA into VA divided by V to the whole square plus V to the whole square. So I am giving one advice. Please remember both the equation. Take it as equation number 6 in your note. Fine. Now write one thing. It can be. So if you, okay, let me first draw once again the table, and after we'll discuss the graph. So draw one table. This is alpha, this is propulsive efficiency of everything engine, that is your 2 alpha divided by 1 plus alpha. Okay, then propulsive efficiency of non everything engine, that is equal to 2 alpha divided by 1 plus alpha square. Fine. Sorry. Now you put the value. First you put alpha equal to 0, so you will get 0. Fine, you will get 0 over here also. Okay, if you put 0.2, okay, 0.4, 0.6, 0.8, 1. Then after you will get around the same thing, 0.33, 0.57, 0.75, 0.88. Why I am writing again, will understand after some time. For here 0.38, 0.68, 0.88, fine, 0.97, 1. Okay, at alpha equal to 1 we get both equal to 1. But here now you understand, at 0.2 the propulsive efficiency for everything engine is nothing but your 0.33, fine, but the propulsive efficiency for the non everything engine, that means rocket engine, 0.38. Similarly 0.557, 0.68, 0.75, 0.88. That means at the same alpha value the propulsive efficiency for the rocket engines are higher than the everything engine, fine, up to the 1. Then after you understand what happens up to 1. If you again increase 1.2, 1.4, 1.6, 1.8 and 2.0. Okay, so now the propulsive efficiency is start to increase for the everything engine, that means 1.16, 1.23, 1.28, 1.33, and if you increase the alpha value again, that means if you increase the alpha value up to infinity, or you can say that means any large number, any large value you can say. So the maximum value for the propulsive efficiency for everything engine is 1.99. You cannot reach the propulsive efficiency as 2. So that it is the last value. Fine. Now you understand. For here 0.98, 0.94, 0.89, 0.84, 0.8. Now you understand this two. So up to 1, if I am increasing the alpha value, then the propulsive efficiency for everything engine is less than the propulsive efficiency for the air non-everything engine, that means a rocket engine. Right? But when I am increasing the alpha value further after 1, then the for everything engine the efficiency is increasing, and for the rocket engine it is decreasing. But in the practical cases we cannot go beyond the alpha is equal to 1 for the everything engine, because we will get the negative thrust. But see, but here for rocket engines there is no any alpha, so the thrust is independent of the alpha, that means the flight speed. So if you are increasing any value of alpha, that means if you can fly your rocket at any value of alpha, but we need to have the maximum efficiency, so we need to have the less than 1 or equal to 1. But equal to 1 is not a you can say the stable case, so always we have to stay less than 1 for the alpha. That's why we will get the meaningful thrust as well as efficiency. Now let's draw this value in a graph. Fine. Okay, let's draw this again. Then after we'll have some wordings. Right. So we need to have for the alpha value. Fine. So somewhere we'll have a 1, so 0, 0.2, 0.4, 0.6, 0.8, 1.2, 1.4, 1.6, 1.8, like this. Fine. At the same time we are having here propulsive efficiency and F divided by MVE. Understand now? Same time. Okay, so let's suppose this is 0.2, 0.4, 0.6, 0.8 or 1. Okay, let me take this. Now we understand. So we have a 2 formula over here, 3 formula basically. The F divided by M V is equal to 1. Okay, first formula. Propulsive efficiency for the non-everything engine, that is the rocket engine, is equal to 2 alpha divided by 1 plus alpha square, and the propulsive efficiency for the everything engine, that is equal to 2 alpha by 1 plus alpha. So 3 formula we are having over here. Fine. Now we understand. So if you go for the propulsive efficiency of everything engine, so you will get around up to here. It is not a straight line, it is some curve basically. So let me draw this again. So this is at alpha equal to 1. At alpha equal to 1. So this is nothing but your propulsive efficiency of everything engine. Fine. Now you understand the propulsive efficiency for rocket engines. So see why I was writing these values. See here it is 0.33, it is 0.80. That means the slope will be higher for the non-everything engine compared to the everything engine. So the slope will be higher. That means it will go around like this. Obviously it will go up to 1 because we need to go only up to 1 from here. Fine. Then after, if we increase after 1, so see here. So if you are increasing after 1 the alpha value, then it is getting decrease, right? So for the everything engine, that means for this you can go beyond this. You can go beyond this, no problem. But still we will have some negative thrust, so no meaning. So for rocket engines, we will have some this one. Fine. So as we go above 1 for the alpha value, so the air propulsive efficiency for rocket engines will be decrease. This is your propulsive efficiency, that is beta P, and this is your F divided by M into V. At the same time, the V, if m dot into VE is independent of alpha, so there is no any graph for this, but still we are having the same graph for this. So basically the last one is for F divided by m dot VE is equal to 1 minus alpha. Fine. The same graph, right? It is a here m of A. Fine. This was for propulsive efficiency is equal to 2 alpha divided by 1 plus alpha square. So understand this. Now let's write whatever I have said over here in wordings. So now write. So it can be seen that see now you can see over here is a for rocket engine the thrust is independent of alpha. That means flight speed basically. So now write bullet. It can be seen that the thrust of a rocket engine is independent of flight speed. It means flight speed means VA. So basically there is no any V over here. You can see also here. Yeah, there is no any VA. That is why it is independent of the flight speed first. Then after, second point, right, is the propulsive efficiency. The propulsive efficiency is maximum at alpha is equal to 1. Fine. One feature I have already told you, right, that alpha can be greater than 1 for the rocket engines, but not for the everything engine. The reason is for negative thrust. I have already told you. So now you write in wordings. One feature different from that of air breathing engine is that alpha can be greater than 1. Greater than 1. If alpha is greater than 1, that means alpha greater than 1, which means that VA divided by VE is greater than 1. That means VA is greater than VA. That means we don't, for rocket engineers, we can have the flight speed is greater than the you can say the jet speed. Fine. No, but already I have said you for different values of alpha, the propulsive efficiency for rocket engines are higher. That is why our slope is little bit slighter higher than the everything engine. Okay, so yeah, fine, 2 points is enough. Now you write, so till now we have done the propulsive efficiency for the rocket engine as well as the everything engine. Now you write the thermal efficiency. Which is nothing but your NTH, ETH, and from our that figure for our energy conservation, all those things, it was B by A. So that unfortunately that figure was not in my tab, FAT. So unfortunately I will not have this, but still we have. Please remember that figure and let's continue. Now you write, basically it's not that much important for efficiency. In our exams only they ask either propulsive efficiency or overall efficiency. Let's see. So the thermal efficiency is nothing but your if VA plus half m dot V minus V whole square. You know why I am writing all these things? And the fuel energy. Fuel energy means nothing but your m dot F into Q plus half m dot of fuel into V whole square. This is your thermal efficiency. This is your equation number 7. Fine. Now you write. Now you write. So that's all for the thermal efficiency basically. So only you need to remember this formula. Although they will not ask directly question for this, but still please remember this formula and all the terms. What are the things are given over here. Now you write the overall efficiency of everything in it. Now you write overall efficiency. Fine. So the overall efficiency is nothing but your C by A, obviously. So the N overall is equal to, basically it is nothing but C. The overall efficiency is nothing but your product of propulsive efficiency into the thermal efficiency. So this can be also a question. If they can give the propulsive efficiency, overall efficiency, they can ask what is the thermal efficiency. Fine. For the rocket engines or everything engine, for both. Okay. In this three, they can give two values for the efficiency and they can ask the third value. So please remember this product. Now understand this. So the propulsive efficiency is nothing but your VVA divided by if VA m dot 2, that means half m dot into VA minus V to the whole square into what is thermal efficiency? The same thing. Let me copy this. Okay, let me take over here. Okay, let me take put this on. Fine. Now we understand. Now you understand. This is your nothing but your F. So this and this will be cancelled out. So you will get rid of the propulsive efficiency. I mean the overall efficiency is nothing but your VA divided by. I'm sorry guys, this is my first time for the, on the iPad, so I'm extremely sorry for this. But in the next class I will be using frequently because I will be practicing this. So actually I was thinking to take the lecture tomorrow or day after tomorrow, but it was delay because I was not taking the lecture from 10 days, so that is why. But please be patient with me and let's continue. So m dot of q plus half m dot f into vs square. Fine. Now if you solve this equation again, then you will get, I'm writing the final result for the overall efficiency for the everything engine. Please remember this, no need to drive all this thing. 2 alpha into 1 minus alpha divided by 2f q divided by ve square ve square plus f alpha square. So here f is nothing but your fuel to air ratio, alpha is nothing but your speed ratio, q is nothing but your calorific heat value. Right? So now let us assume this value as a E. So and so you will get 2 alpha into 1 minus alpha divided by E plus f alpha square. If the f value is less than, very less than 1, that implies that f alpha is equal to almost 0. So if it is 0, then we'll have some overall efficiency for everything engine is nothing but your 2 alpha into 1 minus alpha divided by E. This is only valid when the fuel to air ratio is very less. If it is not very less, then you need to work upon it. Fine. Now this is your equation number. This was your equation number. Okay, let me take this one. This one is a 8. This one is a 8 and this one is a 9. Okay, this one is a 9. not this one. Okay, let's take it this one as a 9. Fine. This one as a 9. So if you please understand, from this we are driving this. So this one is the equation number 9. So for given fuel to air ratio, we can use this, right? But now when you consider the fuel to air ratio is very less, then we can write this same equation as this one. This is your equation number 10. Fine? Not 10 exactly. Okay, 10. Now let's hunt for the maximum overall efficiency. So if there is a overall efficiency, so there is a point at which the maximum overall efficiency we can achieve. So now write overall efficiency for everything engine of maximum. So when you need to find the maximum minima, so basically we need to apply the derivative of any dx or dt something, and after any particular thing is equal to 0. So let's suppose in our case this is our efficiency in which we need to find the maximum efficiency. So d by d alpha of this one, of this value, right? Of this value is equal to 0. So if you find this derivative, so we will get alpha is equal to 1 by 2. So we will get the alpha is equal to 1 by 2, because see, the E is nothing but your, I mean if you take the derivative of this, you will get alpha is equal to 1 by 2, that is equal to VA by VE. So basically so this is your equation number, you can say 11. So what is this actually? So this is the condition for maximum efficiency, maximum overall efficiency for everything engine. So write one question, it can come for 1 mark maybe. Let's see how they can create the question on this. So let's suppose they will ask for air breathing engine, if the flight speed is 200 meters per second, then what is jet speed? So they can ask for a question like this. They will give you, because for, see now, they will first mention for everything engine. So anyhow they need to mention the everything engine, otherwise will not apply this formula. So they need to they need to say what is the they need to say for the everything engine, and they will give us the VA. That means this point we have given as a 200. So we need to find the VA. So what it will be? It will be, so at the time you must remember this formula. For everything in n, if the VA is given and V is asking, so alpha is nothing but your VA by VA, that is equal to 1 by 2. That is the okay for everything in n. Okay, let's we can add one more term by here. Actually, I'm creating the column for everything engine at overall maximum efficiency. Maximum efficiency. Fine. So if maximum efficiency, if the flight speed is given, if flight speed is given, then you have to find the jet velocity. So 200 is given, VE is equal to 1 by 2. That means VE is nothing but your 200 meter per second. Fine. They can ask question like this. Now we understand. So if you put this alpha value over here, so you will get the maximum efficiency, overall efficiency for everything engine. So you will get the overall efficiency of everything engine, that is the maximum at alpha is equal to 1 by 2, or you can say 1 by 2, or you can say the VA by VE. If you put the alpha is equal to 1 by 2, so you will get around 2 by 2E. And what is E? Basically, the E is nothing but your 2FQ divided by V square. That is your 1 by 2 2FQ divided by V square. That is nothing but your V square divided by 4FQ. So this is nothing but your maximum overall efficiency for everything in there. Right, as equation number 12. Now one last term, that is for rocket engines. I'm giving you the directly formula over here. So the rocket engines, for the rocket engines, the overall efficiency for non-everything engine was given as 2 alpha divided by ER plus alpha square. Fine. Alpha square. Now, what is this ER? This ER is nothing but same thing as we have taken this. You have to do the same thing as we have already discussed for the everything engine. So you have to do the same thing, but still no use of this. Please remember the final result. The ER is nothing but your 2Q divided by V square. Right? So now let's hunt for the maximum efficiency. This is your equation number 13. So now let's hunt for the maximum efficiency, because one very nice concept is coming in between. So that is why I'm going directly to the maximum efficiency. So now for maximum overall efficiency, d by d alpha of NO is equal to 0. That means how it is coming, see. So if you drive this from here, so you will write around 2 alpha ER plus alpha square. You apply U by V rule, then you will get around alpha is equal to 100 ER. So after solving this, you will get alpha value because it is derivative. So after solving, please do this here. That means, what is this exactly? What is it is saying? See, this is nothing but your condition for maximum overall efficiency for non-everything engine. So if you go into depth of this, so alpha is nothing but your root under what is ER? ER is nothing but your 2q divided by V square. 2q divided by V square. And what is alpha? It is nothing but your VA by VE. So from here we will get root under 2q divided by VE, obviously, then VA divided by VE. So V will cancel out, so you will get around VA is equal to root under 2q. Fine. This is your question number 14. So they can give you, now understand this. This is very important. This is basically condition for the maximum overall efficiency for the non-everything engine block. That is the rocket engine. So they can give you this Q value. It is nothing but your calorific value. Calorific value. They can give the calorific value, and they can ask what is the flight speed in the rocket engine, basically, right? So they can give you the flight speed, and they can also ask the what is the calorific value for the rocket engine. So basically these are the ways. So now if you put this, alpha value over here in this equation, 13 equation, so you will get around, if you put alpha is equal to root under ER in equation 13, we get the overall efficiency for non-everything engine. That means the maximum overall efficiency for non-everything engine is nothing but your 2 root under ER divided by ER plus ER to ER, right? 2 will cancel out, so you will get around 1 by under ER. That is also is equal to VA divided by under 2Q. This is your basically overall efficiency for the rocket engines. I mean maximum overall efficiency for the rocket engines. Fine. Now write some. Okay, no name. So this is basically this up to here we are having the efficiency for the rocket engines. Basically we have done the propulsive efficiency, we have done the thermal efficiency, only formula, and we have done the overall efficiency. So for the efficiency we are only having the these equations, and these equations are very useful because it can come for 1 mark directly. There is no any question for 2 mark from this chapter, so you can expect the 1 mark from here. So please revise and remember all the formulas. And today I'm using my iPad first time, so it is basically very new to me. So I will take some time to understand this and learn this. So please bear some patience with me, and please revise all these things. The next lecture I will upload within 3 to 4 days, definitely. And please subscribe my channel and share with your colleagues and the friends, whoever needs this. Fine. Okay, then thank you so much for waiting patience with me. Please have patience and study with me. I will complete all the GATE syllabus for the GATE 2026 by the time. Thank you so much. Have a nice day.